Hello students, I am Dr. Tanmay Vishwash. I welcome you all in my channel Chemistry, the Mystery of Molecules. I hope you all are fine. So today we are going to discuss a multiple choice question present in front of you on the whiteboard. Okay. So such kind of MCQ would be useful for exams like bachelor's or master means BSMS, B.Sc, M.Sc or E means college or university level exam upon chemistry. Apart from that, it could be useful for competitive exam related to chemistry like CSIR-NET, GATE, IIT-JAM, etc. So a lot of chemistry to be learned, but before that, I request you please pause the video and try by yourself because self-evaluation is essential for improvement. I believe you have paused the video and tried by yourself. So it's my turn to give you the answer. As usual, what I say, read the question again. What is the correct structure of the major product? Okay, and what I have given in front of you, just look at the reactions very carefully. Sometimes it is true that sometimes questions are given with incomplete info. You have to accept. Now, see, this is a diazo derivative, this is a ester, and I haven't given anything. So, what does it mean? Means generally diazo derivatives are stored in ether. So, you may consider that this is actually a ether solvent, and I haven't mentioned anything means this is RT. These are the common sense you have to develop. Fine. So from these and these reaction, room temperature produces 4 products, and if you look at the options, all are active methylene compounds. I shall come at the end. What about active methylene compound? So initially I shall give you the stepwise mechanism for this process, and at the end I shall explain you within less than 30 seconds how can you solve the question and little bit about active methylene compound. So I request you student, please watch the video until the end with complete attention and in a cool mind. Fine. Now see, actually this is ester, and we know esters are electrophilic. So expected that some nucleophile will attack because I haven't provided any acid base. So nucleophile will attack here. Question: who can act as a nucleophile? Diazo derivative can act as a nucleophile. How? Just as a brief thing, look at this diazomethane. Diazomethane is actually written in this way. We write this CH2N2, but it is not so simple molecules. Okay, so its structure is this. Actually it has many canonical form, means it can come, it can go. So what is the canonical form? CH2 double bond N plus N minus, even one bond could be taken, then CH2 plus, then N neutral, N minus. So in this way, these are the canonical forms. Now look at very much carefully. In this case, diazomethane is in this canonical form nucleophilic, in this canonical form electrophilic. Now question, actually diazomethane what it is? Actually this is nucleophilic. Why this? See, in this case it is an 8 electron species, means all the element have 8 electron, but whereas in this canonical form it's a 6 electron. So simple thing, molecule will prefer to have those canonical form or electronic distribution where its octet is filled. So contribution of this canonical form to the overall structure is expected to be more. Point number 1. And this is what type of compound is this? See, this is a carbonyl. This is actually nitrogen. Okay, this is hydrogen. Now question, this thing we can represent slight different way, means like that. Okay, so how can we represent this? N minus hydrogen. Now you will say, sir, there was one charge neutral species, now you are making charge species, is it good or bad? Actually, how it could be stable? Because if you look at the nitrogen molecule, nitrogen forms nitrogen triple bond valency fulfilled, then how can it forms 2 bonds with a carbon? Okay, it is not traditional because we know that nitrogen can't extend with valency more than 4. So maximum valency is 4 because nitrogen do not have energetically accessible vacant d orbital like phosphorus. Phosphorus, which can extend its contribution from 5 up to 5, 6 like that it can. So fine. So this what we are writing, it's an average structure, but it is not the exact thing. So what happens? So this, and why this is, I'm saying this has a stability also. Why? It will come, it will go. So what it will result ultimately? So this is O minus, this is N. Okay. So in this way this is stabilized. So you can consider that if you compare this versus this, a simple question, who is more reactive? Obviously diazomethane. First of all, this is 2 proton attached to this. In this case 1 proton, 1 ketone. Point number 1, bulkness, steric factor, because since it is acting as a nucleophile, so bulkness of the nucleophile is also important. Point number 1. Point number 2, see, in this case the charge density on this carbon is more. You can say that, sir, there are delocalization using this part. I agree. Same thing is applicable for here. But in addition, there is another delocalization of the negative charge on carbon using this carbon. So from this what we can conclude? That nucleophilic center is this. Nucleophile means negative charge density is less. Another thing, bulkness is more. So apparently it seems like this is less reactive. Okay? Relatively less reactive compared to diazomethane. And remember student, diazomethane is a dangerous compound. Why? Because during the reaction it produces nitrogen gas. I shall show that during the mechanism you can understand. So that can often result in explosion. So while you are working in your laboratory, always follow the safety precaution, and please be careful while dealing with diazomethane and read properly while before heating the diazo compound, because nitrogen is produced in this reaction. So nitrogen actually NN triple bond, very stable molecule, huge amount of energy release, and there is a driving force for nitrogen preparation. See, in this case what I told, this is actually minus and N2 plus. So you may consider this nitrogen, first of all it's a neutral molecule, second is a gas. So it want to come, so at a particular time huge amount of gas comes out, means that may result in explosion. So please be careful. Now, fine, we understood. Now question, we got it that it is not that much active. Now simple thing, why it will react? It will react because this is actually a aldehyde derivative, means it's a format ester, means there is a format. So carbonyl attached to one oxygen derivative, one hydrogen, so bulkness is less. And we know there is one term named Burgi-Dunich trajectory. Student, please learn this. I have already described in a dedicated video about this concept. Burgi-Dunich trajectory. What does it mean? It means that how the nucleophile will attack to the carbonyl group in order to have a addition reaction. Okay, around 170 degree near about, and in case of aldehyde reaction is faster, in case of ketone less. Why? Because the steric repulsion is less in case of aldehyde, because this is hydrogen. Another thing, plus I effect also absent. What do I mean by the statement? So in this case, if you consider this versus this is less reactive. First of all, plus I effect of methyl group, second bulkness of the methyl group. Okay, so this also plays an important role. Now, so we have understood this part. Now question, how it will react. So this negative charge will act, open up. In the meantime, what it will do? So this is the O minus, this is the hydrogen. In this case, this is carbon attached to hydrogen, this is nitrogen. Sorry, this is nitrogen, this, and another thing is this is the ketone. Now question, what is expected to happen? As I told just some time before that N2 is one of the best living group. So it will live. Now question, how it can live? Normally it can't live. Two options. One, that it will attack here epoxide formation, it will live, but remember epoxide is a 3-member ring, not that much stable. And second, based on your common sense, I didn't mention anything. Second option, that it can push, this hydride can migrate, this can leave. And in this way, what it will result, expected to result, this is O, this is double bond, write everything as it is. This is C, this is one hydrogen, this is one hydrogen, this. So why I say write everything, you do one step more, but do in this way the chances of mistake is less. Okay, in next step what can you expect? Just nothing, just rearrange this 2 hydrogen, this and OET. So question this is the answer. So what is the option? So in this case option B is the right answer. Fine. Now, so we have understood this. Now let me tell you within less than 30 seconds how can, okay, another point I forget to mention, that remember this active methylene group could be prepared very easily using Claisen ester condensation. I have already discussed many videos and MCQs. Please visit if you have any difficulty on this concept or if you want to learn more. Fine. This Claisen ester condensation, it could be easily prepared. Then question, why we should employ such kind of difficult reagent? This is a diazo derivative for this reaction. One point, because of this mildness. And I have already described this thing in a Roskmap reaction. Okay? Roskmap, KMP, KROS, Roskmap reaction. Okay, so here you can understand that this reaction is very much famous for its milder condition. What do I mean? See, in this case you don't need to heat anything, just in room temperature you get the product. Point number 1. Second, I have discussed this thing in that lecture, Roskmap reaction. You visit that active methylene compound. For example, if one hydrogen is replaced by R. For example, what do I mean? In this case, if you replace this by R, then you will finally end up this R. And this is actually chiral center. 1, 2, 3, 4 different. So this is chiral center. But can we get enantiomer selectivity at this carbon? Generally answer is no. Why? Because tautomerization possible. What do I mean? They can easily undergo tautomerization. So this thing you can consider this and this. And this is stabilized because of this hydrogen bonding intramolecular. And this thing is accelerated when you increase the temperature. So if you want to have the asymmetry at this carbon, so you must be careful that reaction is milder enough, and that is achieved in this reaction. Okay, so this is the uniqueness of this reaction. Please remember. Now question is, if this question is given for you in your exam less than 30 seconds, how can you explain? First of all, you need to understand N2 means there is this and this. Point number 1. Second thing, it's a format ester, very good nucleophile, so it will attack. And I suggest you student, please draw this structure on your pen and paper during the exam. Only this, and you don't need to think. So in next step, so either epoxide, and second thing, this hydride could be migrated, because we have learned a lot about this hydride migration. Okay, so it will migrate and ultimately it will leave. So there will be double bond carbonyl, this dicarbonyl, and one part is ester. This much amount is enough. Dicarbonyl, everything is dicarbonyl. One part is ester, in which case one part is extra. This you don't need to go more also, because questions are constructed in such a way that they are easy to solve, but you have to realize the tricks how to solve. Okay, and always I request you, please read the basic chemistry knowledge or name reaction thoroughly. Don't follow the tricks at the initial stage, because if you are lucky enough, you will get easy question. If you are not that much lucky, you may end up in a great trouble in the exam hall. And always remember, when you have good preparation, your confidence level will be high, your mind will be cool in the examination. So it is highly probable that you can find out the right answer easily in the exam hall, such that you can secure a better marks. Okay, so this is the discussion. And another thing, why these active methylenes are useful, because this proton could easily be abstracted using a base, which will result a negative charge here. Means what do I say? Is negative charge here means you can generate a nucleophile easily in this position, and that's based on that you can do lots of like Michael addition, Lorentz addition, lots of things you can do. So that is the beauty of this active methylene compounds also. Okay, so I have already discussed in some dedicated lectures. Please visit if you want to learn more. So this is the end of this discussion. I hope this video may be useful. Please write your opinion in the comment box, and I request you, please subscribe, press the bell button, and share among your friends. And most importantly, I need a favor from you people. So if you are capable, then please support me through Patreon. Otherwise, it's very difficult for me to upload such kind of videos for you on a regular basis. So thank you again. Stay happy, stay blessed. See you in my next video.